for his research project entitled on the asphericity of some relative.
Can I start now? Good morning to everyone. Today I will be presenting on my research project on the asphericity of some relative group presentations of this form. So this is the outline of the presentation. We will first go through some definitions of some terms that will be necessary for the slides behind, and then we introduce the research objectives, and we will briefly discuss about the test for asphericity and literature review. Then we will present our main results and conclude our presentation. Relative presentation is a triple, where H is a group, and the set X is a set of generators, and the set R is a set of relators. And the words in the set R has this form, and they are assumed to be cyclically reduced. We call the elements in the set X as X symbols and elements of H as coefficients. And the length of this word is determined by the number of X symbols in it. So here we consider an example, and clearly we see that this relator has length 2 because it has one X and one inverse of X. And a picture is essentially a graph in the sense of graph theory, and there are 3 important aspects to a picture. We will look at one example later, but the first aspect is a picture is non-trivial if it has more than one piece, and the second one is spherical. So we consider the relative presentation we considered just now in the previous example. So this is a spherical picture over the relative presentation. So there are some terms. The first one is this. This is given by the circle here. And then the arcs are given by the line here, which are connecting the discs together. And corner is the area around the disc, which are separated by the arcs. So here, this disc, it has 2 corners, given by the corner here and also the corner here. And the region is the area enclosed by the arcs and the disc. So here is a region, and because this picture has more than one disc, more than or equal to one disc, so this picture is non-trivial, and this is also a spherical picture. So, and because this is a spherical picture, we omit drawing the boundary, the big circle outside of this picture. And now we will talk about how we label a picture over a relative presentation. So we label the corner by the coefficient, the elements of group H, and also we label the arcs using the X symbols with the arrow indicating its direction. And we say that a picture is over a relative presentation if 2 conditions are satisfied. The first one is if we read the labels around a disc in anti-clockwise order, we obtain the relator in the relative presentation. So here we see that we have x2 element of x1, which is the relator of this relative presentation. The second condition is if we take the product of all the corner labels inside a region in clockwise order, we get the identity in H. So here we have 1 plus 1 plus 1, which is equal to 3, which is equal to the 0, the identity in Z subscript 3. And now we consider the third important aspect of a picture, and this requires the definition of a dipole. So we can straight away consider an example. Informally, we can kind of see that the terms here cancel out each other. So here is x, here is inverse of x. They cancel become one identity, cancel each other, and so on. And we say that a picture is reduced if the picture does not contain a dipole. So now we will introduce our research objective. We aim to investigate the ability of relative presentation of this form given by these two conditions. And we remark that we have already reduced the number of cases to be considered using these two conditions here. Now we will briefly discuss about tests for ability. The first one is diagrammatic reducibility, and so if every spherical picture over a relative presentation contains a typo, then the relative presentation is aspherical, means not spherical. We usually use this method to determine the ability of a relative presentation. The second method is weight test, whereby we first draw out the star graph of a relative presentation, and then if we can assign a weight function on the edges of the star graph such that three conditions are satisfied, then the relative presentation is aspherical. The one is curvature test. So we suppose that we have a picture. Suppose that we have a connected, spherical, non-trivial and reduced picture, and then we kind of fold the picture out into a two, such that the picture tessellate a two sphere. Remember that the inside of two sphere is empty, and then we note that there are twice as many corners as arcs inside of such picture, and also the Euler characteristic formula for two sphere is 2. We obtain the curvature of the picture of such picture is 4 pi. So it means that there will it means that this picture will always contain some regions that have positive curvature. And using this knowledge and the condition that the product of corner labels inside the region of a picture reaches the identity in H, we can determine the possibilities of the corner labels in the region with positive curvature. Curvature distribution method is applicable after the curvature test. So in this method, we consider back the same picture before, and we first locate the regions of this picture that has positive curvature, which we shall denote by delta. And we locate the neighboring regions around delta with negative curvature, which we denote by delta hat. And then we distribute the positive curvature of delta to delta hat, such that the curvature of delta is now 0. So we focus on the curvature of delta hat, and if the curvature of delta hat after receiving the positive curvature is non-positive, means smaller than or equal to 0, this gives us a contradiction, because previously in number 3 we mentioned that the curvature of such a picture is 4 pi. So this gives us a contradiction. So it means that such a picture does not exist for the relative presentation, and then we say that the relative presentation is aspherical. The last method, this method we apply a lot in our research, called the change of presentation. There are 4 important steps. They are named T transformations. So what we do here is we establish an equivalence between the relative presentation that we are studying with another relative presentation, whereby its aspherinity is already known. So this can help us to save some time and effort. And literature review. There has been much interest on relative presentation with relator of free product length 4, and also of this form. We will focus on number 2 because number 2 is related to our research. So it has been researched up to and including length 6. So for length 2 and to length 4, we have a complete classification of the results, and we note that the results for length 2 is trivial, and we only have partial results for length 5 and length 6. Now we come to our main result. This is our first research objective, and we see that this relator, the length is an even number because 2n plus 2n is an even number, and using the fact that just like in the literature review, the aspherity of this form has been researched up to length 6 only, so we consider the length of 4, 6, and 8. So for length 4, there is only one possible combination of m and n, so 1, 1. So we consider only one relative presentation. Length 6 also similarly to 1. There is another length 6 presentation actually, 1, 2. So this one should be x squared a, x to the power of 4b. But because we have this condition here, so we only consider 2, 1. Because the other relative presentation, the x squared a, x to the power of 4b, is equivalent to this one. So we can choose to consider only this one. And this is what we mean by the beginning. We have already reduced the number of cases to be considered using the conditions here. And length 8, there are two possible combinations. So we consider two relative presentations. So how do we obtain the aspherity of all these relative presentations? We will take length 6, this one, as an example. So we consider this relative presentation. We will first apply the change of presentation. I will show here roughly just some steps. So we have something like this. This is equivalent to x squared. And we see that this relative presentation is equivalent to a length 3 relative presentation. So we can search for available theorems on this length 3 presentation, and we found this theorem in this literature, and subsequently we will modify the arguments of this theorem. Here we have xa, xb, xc, but here we have x squared a, xb. So we can replace the a here by 1, replace the b here by a, and c by b, which consequently will give us this theorem on the aspherity of our relative presentation. And we also provide the spherical picture for condition number 1. So this is the spherical picture. So there are two important things here. The first thing is, if we read the order of this label in anti-clockwise order, we obtain the relator x4a, x squared b. So we see that, here x squared, x4a, x squared b. So this is the first thing. The second thing is if we take the product of all the corner labels in clockwise order, we obtain the identity in H. So here A has order 2 is given here. A minus inverse of AB has order 3 is given inside here, and order of B is 2 is given here. So this length 4 can be reduced to a length 2 presentation. So the inside here is a minus 1b, but is equal to that one because the order of an element is always equal to the order of the inverse of the element. So this is length 8, but it can reduce to length 2, and this theorem is similar to the one before, but here we consider a spherical picture whereby the order is 3. So we have an hexagon here. So this length 8 can be reduced to length 4, and we give the spherical picture for condition number 3. So we have this picture. So order of A is equal to 2 is given inside here. AB inverse is given inside here and also outside here. Order of B is 3 is given in, order of B is equal to 3 is given here, the outside here. So we conclude this is the first objective, and this is the second objective. And clearly this one is a related of length 2. So we consider length 4, 6 and 8. So length 4 only one possible combination. Length 6 also, there are 2 combinations but they are similar, equivalent, so we consider only one. Spherical. So this is one of the spherical picture. This one we give for the picture for number 1. This one we give the spherical picture for number 1. So we have a squared equal to 1, a equal to b squared, means that a b minus 2 is equal to 1. That one is given here, I think. Yeah, here. Also, this means that the order of b is equal to 4. And that one is given inside here. So this is the last one. We have an octagon because order 8. So we have obtained the stability of this relative presentation. We apply the change of presentation and then we modify the available theorems. And the core idea is, before we immediately apply the stability test, we can consider using change of presentation to reduce the number of cases to be considered. And this idea is also used by other research as well. These are the references. Thank you.
You're doing a coursework. You're doing a coursework mode, isn't it?
Yeah.
So this is not a thesis. This
Yeah.
is a dissertation.
Oh, okay.
This correct, huh?
Okay.
I want to comment on your style of writing.
Mm.
I know it's okay to write definitions in a passive way, not the definition of a theorem thing. It's okay, but when you write something, you want to define something, you have to spell it out in the wording. Say, we define blah blah blah. You have to use the word define inside the wording. It's okay not to put a title or definition.
Okay.
Right? Or you can use words like is called, something like that. Right? Just to tell the reader that you are defining something.
Or means to put the definition inside a paragraph rather than something.
It's just right in a natural way.
A natural
you
way.
define a group as not, a group is a set with operations. You just put the clause, we define a group as a set with some operation.
Okay.
So the word define is important just to emphasize that you are defining something.
Okay, I will change that.
All right. And I think you have to be careful when you use the word theorem, because theorems are big results, right?
Yeah.
They're not just only a result which corollaries to other theorems. Because your contribution, I know you have contributions in chapter 3,
Yeah.
but some of them are just, it's not fair to call them theorems.
Okay.
Because they are just small results, corollaries to other results, right?
Okay.
Which you quote nicely. I mean, it's a well-written work. I must give it to you. But I just want to tell you that theorems are big results. Right?
Okay. I will
And
change that.
one more thing I forgot. I don't suppose you write your dissertation without the pictures. Is it okay?
Yeah, it's okay, but I think the chapter 3 and chapter 4 does not have any pages.
Yeah, that's my point. That's my point. Because your main result, you can prove it using the equivalence form, and then you record some theorems, past theorems, and you use it in your proof.
Yeah.
And it stops there. So the role of the picture is what? To inform the reader what?
Okay. Because for the articles they did not provide a picture, they only provide some of them. So I try to provide one picture for each of the relative presentation.
Yeah, fair enough, it's okay, but
Yeah.
what's the role? Does it enhance the proof or does it gives a better picture of the situation? Or what? Because I'm not, this is not my area, so I'm trying
Oh.
to figure out what's the point of all these pictures if we can prove it using just equivalence form and corollaries to other result.
This one is just for you to enhance the result only, not to enhance the proof, just to enhance the result.
Enhance the result, okay.
Uh,
Because I'm not in this area, so
okay.
I'm done for now. I'm done.
Okay, this is a simple question from me. Okay, so the first thing, your report does not contain your content. See? Does not contain your content in your report.
You mean the content of chapter 1?
Yeah. Okay. So at first I cannot see the whole story.
Oh, I think I forgot to put that.
But it's okay. Okay. In your report also, I noticed that you provide many examples.
Yeah.
Okay. So how do you get the example? You create or you get from somewhere?
I refer to thesis by other people. I think one thesis is by Prokafu and another by Sultana Elway. So I refer to their thesis. They did provide example, but my examples are quite different from theirs. I just get the idea.
So I think if not from yours,
Mm.
so you should put the citations.
Oh, but I think those are my exam. I think 1 and 2 are quite similar.
Oh, okay.
So if the examples are similar to I still need to put the citation.
Okay. You should put
Maybe you have to say that this example is motivated by examples provided by.
Oh, okay.
So one more.
Mm.
Can you show the objective? Okay, I just a little bit confusing with the MN.
Yeah.
Okay. In this case, you say that MN integer.
Mm.
Okay. Okay. So the other cases, you see that M positive and M integer negative integers.
Yeah. Okay. So for positive,
We have two types of that.
no, actually they are similar in the sense of they have the same length, but I put positive and negative because in the picture the drawing of the arcs will be different. The arrow will be different.
Okay. In your finding also,
Mm.
you just give the result for certain value of M and N.
Yeah.
Okay? Not for the general cases. But you conclude for general.
But I put the, is it okay I put the word for some M and N?
No, if you see that the list down of your result,
Yeah.
okay, you consider for M, for the 2 length, 6 length,
Yeah.
okay, okay. Is it considered for the whole M?
No. We just consider some special cases of M and N also, as only. We do not consider the general result.
But in this case, you conclude that for the general result for any M N. But in your proving, you just consider for certain value of M N.
Oh. Okay. So I think I changed my research objective to be more specific.
I'm not sure for that, but
For some, did you say that for
for
some?
some.
I put the word some
in your
because
proving,
we
in your
only
proving.
in the proving.
In chapter 3, in chapter 4,
Yeah.
okay, you just give the result for the certain value of M and N. For example, 1 minus 1. You can see here.
All this one is because we first consider the length of the relative presentation. So for length 4, we have 2n plus 2n. So 2n plus 2n equal to 4. So we can choose m equal to 1 and n equal to 1. So get length 4. Something like this. So the values of m and n depends on the length of the relative presentation.
So for this case, what is MN?
So for the chapter 4,
Yeah.
for length 4, we have m equal to 1 and n equal to -1. There are another cases which is m equal to -1, n equal to 1, but actually both of these are equivalent to each other. So we only consider one of them.
Like in this group.
I think it's not correct to sub for some and on your items.
Oh.
Because the M and N are for your group, right? And then when you focus to the special case of when N less than equals to N, then only is for item 1. When N is positive, where N is positive, and then is only for item 2. So for some in the last 2 lines is not appropriate. Because the M and N is for the whole group.
Yeah.
Isn't it?
I think maybe I
think it's
change
just
the
matter of
wording.
wording. As far as I see it, it's matter of just wording.
Okay, I think I change the wording to be more appropriate.
Because when you put for some at that stage, at the last 2 lines, that comes in the question of why that are your M and N. Whereas the M and N are fixed from the top.
Okay, I think I understand the problem now.
Are you from mainland China?
No, I'm in Malaysia.
No, Malaysia.
That brings me the question, why is you writing in English?
Untuk research project boleh pasal ni.
Yeah.
Untuk justifikasi, sebab semua kursus in English.
Datang saya tanya last time lagi saya still okay.
Okay.
But I suggest to write in Malay.
If it's a thesis, yes.
Yang ni dipanggil research project report.
Okay.
Okay.
Okay, thank you.